So hi everyone, welcome to Big Data Champs, and this is the second session of our Big Data series that we've started. And in this session, what we'll be learning is like I'll be covering a high level overview of Spark, and I'll be also discussing about the advantage of Spark over MapReduce and why companies are like almost all the companies are using PySpark over like MapReduce, and what are the challenges that we already discussed in the earlier session. So you can watch that session if you haven't watched yet. And we will also be covering an on-premise and cloud infra, and what are the difference between them, and which one is being used, basically in which scenarios, which type of infra is used by the companies. So that we will be covering. And so let me recap what we have discussed in the session one. So in the session one, we discussed about the big data, what is big data, and how we define the big data, what are the different factors. We understood the 3 V's definition. Okay. And we discussed about each and every uh, you know uh, uh, factor that basically define the big data. Then we discussed like different type of system, like a distributed system, or monolithic system, traditional system we also can say. And then we discussed about the core component of the Hadoop, basically Hadoop. We covered the Hadoop overview. That is nothing but a ecosystem of tools uh, that has like 3 core components that we discussed, and these 3 core components is basically used to build a big data application. And then we discussed the challenges with Hadoop, and we discussed these challenges. So one challenge I forgot to mention in the earlier session. So it is the so basically MapReduce is kind of like very less flexible, and it can only be used with SDFS and yarn. So when we were discussing about the 3 core components, so what were the 3 components? 3 components were the SDFS, then we have you know MapReduce, and then we have the yarn as a resource manager. So MapReduce is a processing engine. It can only be used with Hadoop, sorry, with SDFS and yarn. Suppose if I give some another storage like S3 on AWS, or let's say if we have you know GCS from GCP, Google Cloud, or ADLS from Azure. So instead of giving HDFS, if I want to use these storage, then MapReduce won't work there. MapReduce can only work with HDFS, and it can only work with yarn, because we also have some other options like Mesos is there, Kubernetes is there. So but the MapReduce can only work with yarn. It cannot work with these resource manager. So so in that sense I am saying it is less flexible. It can only be used with these other 2 components. So that is the flexibility part, and the MapReduce is like flexible in that term. So that so now we have also covered this. So let's move ahead and understand. So I want to tell something like whenever, so instead of, if you want to build a scalable big data application, you need 3 things. Along with, I'm considering we it is by default that we will be using distributed system only, because in monolithic system we won't be able to develop our big data application, because that is not scalable thing. So we will need 3 things along with the distributed system. I'm like considering default we have distributed system. Now what else? 3 things we need. So the first thing is distributed file system. Another thing is distributed processing engine. The last is resource manager. If you want to build any scalable data pipeline, data application, big data application, you always need these three things. You always need these three things along with distributed system. Along with distributed system. So distributed system though is compulsory, वो तो चाहिए ही हमें. But along with that, we need these, file system, processing engine. So the distributed system is a physical part. It's a hardware, I would say, hardware. And we also need software. So this is the software part. These are the softwares that we need, just like to explain in very layman term. So we need these three things. How we will get three things? Who will provide us these things? These three things. So Hadoop has already like three core components. What are the three core components of Hadoop? Hadoop was providing us what was providing us Hadoop core components. uh, what was that? So Hadoop core component was HDFS, MapReduce, and what was the yarn resource manager. So Hadoop already have these core components, and that's why we are able to build big data application using Hadoop. If Hadoop don't have any of the component, then we won't be able to build application, big data application. So Hadoop has all three components that we require to build big data application. Because HDFS is what? HDFS is nothing but the distributed file system. MapReduce, it is distributed processing engine. What is yarn? Yarn is a resource manager. So it is there in the Hadoop. That's why we are able to build big data application in Hadoop. So this is something that I want to cover. So suppose tomorrow if a new data processing engine come into the picture, then we can you know we can we will try to use it instead of MapReduce, because it is these are the options. These are the options available that we are using. If we have some other options, so HDFS is not the only distributed file system we have. There are other file system also. For example, on AWS, for AWS we have S3. On Google, on Google Cloud, what we have Google Cloud Storage. And on Azure what we have uh, ADLS. We have ADLS. So these are the options we have. So it is not only HDFS that is the only distributed file system we have. We also have these things available on the cloud. HDFS is more of when we say HDFS, it is more of a on-premise. I'll be covering all what is on-premise and cloud in this session only. But just for now, try to understand this. Instead of MapReduce, what other option we have? We have Spark. We have Spark. We have Spark. Instead of Yarn, what we have? We have what we have? We have Mesos. We have Kubernetes. So this is the thing. If you want to build any big data application, you need these three things, and we have multiple options. Spark. We have Databricks. You know. Uh, so there are multiple options. I will be covering everything in depth. So for now, what I'm trying to understand, explain in this with this is HDFS, MapReduce, and Yarn is not the only option to basically build a big data application. We have multiple options on the cloud. Different cloud providers provide different services using which we can build different scalable big data application. And we have already covered MapReduce can only be used with HDFS and Yarn. That is the limitation of it, and that's why we have the people have developed different tools and services which are portable, which are more flexible, and that we will be covering. Okay, so that is the thing. Let's start with this session. so so what is so we will be covering like Spark. If I say Spark, so what is basically Spark? Spark is again a distributed processing, you know, engine, distributed processing engine, or I would say it's a in memory distributed processing engine. It's a in memory distributed processing engine, and yeah. So what I mean by in memory, again, I'll be covering that. Just you know, follow me. Okay. So what are some advantages of Spark, which basically help us to basically solve all the challenges that we were facing in the MapReduce. So Spark is again just a distributed processing engine. Spark can be compared with MapReduce. Uh, Spark cannot be compared with Hadoop. Hadoop is an ecosystem. Hadoop is whole ecosystem. It is not a processing engine. It is like a collection of core components. It has its own core components. It's a collection of tools, I would say. But Spark is like an individual thing, individual that is comparable to MapReduce, similar to. So Spark is you can say people have developed a more enhanced version of distributed processing engine, and it is faster than Spark is 10 to 100x faster than MapReduce. Okay, so it is faster than. So let's discuss each and every advantages in bit detail. So the first is it is very flexible. What do I mean by flexible? So it is kind of it is I would say distributed processing engine that we you know we can use with different available uh, distributed storage or distributed file system and resource manager. It is not limited to MapReduce. It is not basically limited to SDFS yarn. So, like in MapReduce was limited and can only be used with SDFS yarn, but in case of Spark it is not the case. Spark can be used with other these options. So for example, if we build a big data application with Hadoop, or I would say using Hadoop, then what my three things will look like. SDFS, I'll be having uh, MapReduce, I'll be having yarn. So if I want to build a big data application, what all things we require? What all things we require? We require distributed file system. We require processing engine. We require resource manager. So if I use Hadoop, so what is the distributed file system that Hadoop provide? It provide SDFS. It provide MapReduce. It provide Yarn as a resource manager. So if I use Hadoop, then I'll have these single option only. But if we build a big data application using Spark, then what are the different combination we can have? So what are the different combination we can have? So let me show you. Mm, I'm just trying to make it more visualized for you guys. So for distributed file system, what we can have, it can be used with HDFS, it can be used with S3, and we can have GCS, Google Cloud Storage from Google Cloud. We can have ADLS, Azure Data Lake, storage from Azure Gen 2, and these are the options we have for distributed file system. What option we have for processing? For processing, what we'll be using for Spark. Okay, and if we basically use Spark, we have these options for distributed file system. And what options we have for resource manager? We can use Yarn, we can use Mesos, we can use Kubernetes. So we have these different options, and for resource manager. So basically, Spark providing me greater flexibility. Spark providing me greater flexibility in terms of options for resource manager and for distributed file system. So that's why I'm saying it is very flexible when it compared with the MapReduce. So this is the first advantage. Let's move with the second advantage. It is relatively easy to learn when uh, compared to MapReduce, because we can write we can write code using Spark, data frame, APIs. We can use you know Spark SQL. We can basically just write a SQL query and we can process the data. That is like the simplest possible solution you have. You just write a SQL query and your data will be processed on the basis of that. Or you have another option, you can use data frame APIs. You have like different transformations and in Spark that we will be covering. And we also have the core API, which is RDDs. We can use RDDs, the core API only. So you can see, I'll be covering everything. These things I'll cover in very detail. But for now, I'm just trying to give you a high level overview, like how Spark is, have advantage over MapReduce. So Spark is like easy to learn when it compared to Spark, because when it compared to MapReduce, because in MapReduce we have to write the Java code, and we have to write like a lot of code to just implement a simple logic. So that is the thing. The another thing is, it is faster. It is 10 to 100x faster than MapReduce. And what is the why it is faster? You must be asking, like, bro, like, why it is faster? Because in I have mentioned, it is a in-memory distributed processing engine. This is the reason. This is the reason, and there are other reason also, but this is the like one of the main reason. And I'll cover in what does it mean in the next. So otherwise, like, if I just start explaining this now here, it will take a lot of time. Okay, and I'll have to deep dive into the Spark. For now, I'm just trying to give an overview only. And the next thing is, it can do batch as well as uh, streaming processing. Okay, it can do both, but MapReduce was doing only batch processing. Okay, so these are some advantages of Spark, and that's why the companies are like using Spark, and mainly I would say uh, only the like if the companies have like legacy application, so only those company applications are like being maintained in the MapReduce framework only, or they are trying to migrate the these MapReduce applications to the Spark application. So these are the things that happening, and basically almost all the companies are using Spark. So let's now move ahead with the second thing is the comparison of cloud and on premise. So let's discuss like what is on-premise and cloud is there. So 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 we know we need distributed you know system to build a scalable big data application. Okay, we need this. And how the distributed system look like, I showed you in the last first session is like this. So the distributed system is look like this. So we have multiple machines, worker nodes, and we have the main master nodes. So at high level, what I want to say is we need multiple machines. And on premise mean you will own, you will purchase these machines by yourself. Okay. So on premise, what does on premise mean? So what does on premise mean? So you will basically you own the hardware and the software to build the big data application. So you have to purchase the hardware. Hardware means these machines that will requires that will require to for the distributed system. We if we have to set up this distributed system, we need these machines. So this is the hardware part. So we have to purchase basically these hardware and the software as well. So we'll be owning the software that will be installed on those machines. Okay. So that is on premise at high level. And so let's discuss more in detail. So what I want to say, we need to buy the machines and set up the networking, because these machines has to talk to each other. Then only we will be able to process our data, because once our data will be processed, the result has to be sent back to the master node, and that's how it will return back to us. Okay, so these machines has to talk to each other. So that's why the networking part is also be there. And okay, so the next thing is we need a we need space. Obviously we need space to basically hold these machines, and we have to also take care of the maintenance part, and we also have to take care of maintenance of these machines. Cooling, because these are the hardware that will be running all the time, and it need cooling. I would say the air conditioner has to be installed to keep them cool. Otherwise there will be failure happening. Another thing is uh, updating the softwares time to time, or patches, and take care of the security. Okay, so we basically need an entire admin team, need a separate admin team to basically to do all this system upgrade security part. So we need a separate team to do this. Okay, and the another thing is we cannot scale it uh, you know efficiently. So what I mean to say is, if suppose unexpected demand comes, for example, like if Amazon is using on premise, and they have just a limited number of machines in their distributed system, and in the festival season, like Big Billion Days or something like that. So there will be a lot of what I want to say, the demand will come, and your machines and your system has to take care of it. It should not fail in that situation if a lot of traffic is coming to your application. So in that case, you cannot just add multiple machines, buy multiple machines at that time only and add into your network. So that is not something that is we can do here. Okay, either you have to purchase a whole lot of machine in advance and already keep them in your environment or your system, then only you will be able to take care of it. But in that case, there will be a lot of wastage of resources. Wastage of resources. Why wastage of resources and money also? So because suppose in the non-festive season you won't be having the demand and that traffic to your website or application, and in those scenarios, in those cases your resources will not be used. So we like they will be running, but that those are will not be used. So that's why I'm saying this is the wastage of resources and money as well. And the another thing is it require huge capex and sorry capex and opex. What do I mean by that? Capex is the capital expenditure, the initial upfront cost that you will be like purchasing your machines, and you will be you will be buying some space or renting some space. So there is an upfront cost, a high upfront cost that will require, and again there is an operating expenditure as well. What are the expenditure here is nothing but the maintenance. Okay, so the maintenance cost will be there. Maintenance cost that you will be doing time to time. You will be having admin team. You have to pay the salaries to the admin team. Okay, so that is operating expenditure. And other will be like there will be some hardware failures as well. Hardware failures. Hardware failures, and you have to again like replace those parts in the machines, and you have to take care of that. So these are the things that will be coming your way if you are using on-premise setup. And then last thing is no recovery option in case of some in case of disaster. Because if you have some disaster in your area where the your on-premise setup is installed, if you have like some disaster, then in that case that whole setup will be destroyed, and there will not be any recovery, and you will lose everything there. Okay, so this is the on-premise thing. So now let's discuss about the cloud setup. So we have discussed the on-premise setup. Okay, now we will see how we will be doing a cloud setup of our distributed system. Okay, so in cloud, so basically we have like main three cloud providers, and what are those providers? Are nothing but uh, cloud providers. What are those? We have AWS, we have GCP, and we have Azure. There are other as well, but these are the market leaders. Okay, so what is basically what are cloud provider mean? What is cloud mean? Cloud setup mean? So cloud mean like the hardware and software say will be provided by the cloud providers, and these can be accessed through web UI. Okay, so these cloud providers basically have their data centers, and what are the data, what does data center mean? Let me show you. So data centers are nothing but a collection of a lot of like machines and servers, I would say. And they have connected, they have also done their networking part, security part. So these are the things then that are basically taken care by the cloud providers. So they have like there's these data centers in different countries, and that too in like different regions of that country. Okay. So basically what we can do is we can rent these machines, okay, for our use. And once our like work is complete, we can basically release those machines. Okay, so let's go here and see. So so these are the cloud providers, okay, and they have their own data centers and in the different countries and region. And we will be using those data machines present in those data centers. Okay. So we so in cloud setup, we do not need to buy the machines to set up our distributed system, you can say, or uh, big data application. Okay, because cloud provider will be providing these machines to us. And cloud provider will be take care of the security part also. Cloud provider will take care of security part. And and we do not have to spend upfront cost basically to buy the space that we were doing here. And so what we were doing is we were in the on-premise, we had to like buy space infra to basically keep those machine and but in cloud, because those machines will be present in the data centers that are like already built by the cloud providers. So we do not have to do the capex. uh, so no capex required. And uh, it only require you know uh, we just have to pay what we will be using. Means pay as you go. Indirectly at high level, I would say we are renting those machines for the time like when like our application will be running. And once our work will like once we do not require those machines, we can basically release, and you won't be charged later on. Okay. And here in this case, we can like it can be scaled efficiently whenever required. What I mean by that is like in the what I want to say is like in festive seasons, there will be a lot of demand and traffic coming to your data application. For example, we take the Flipkart. So in the big billion deal, there will be like a lot of coming traffic and demand will be coming. And in those scenarios, you need more servers or more machine to basically support your big data application. Okay, to process that whole lot amount of data. Okay, so in those like couple of scenario, you will need some machines. And after that, in the normal season, you don't need those machines. So you can, if it, like you can release those machines in whenever do not require. And like if a sudden requirement came, you can easily scale your application, so it can be scaled very efficiently. Okay. So here basically we it provide uh, disaster recovery options. So as I mentioned, we will be having like data centers in the different countries. Suppose you have stored your data in like in some of the data center in India, and replicated the same data on some other data centers. So in if like the disaster come to in a particular like, country or city, so our like replicated data will be like safe, that is like present on the other data center. So in that case, you can like high level, I'm explaining, your data or application will be uh, safe. Okay. And it also provide us a geo I would say low latency. How? uh, because it provide uh, geo distribution. Same thing, the data centers are present in the different locations, geolocations. So if your like customer base is in US, and also your customer base is in India, then you can have your application hosted at two different places. So suppose if the users from the USA basically trying to access the application, they will be able, so those requests will go to the USA data center. And if the user in the India will be accessing your application, then those requests will go to the data center that is present in India. Okay, so that's how we will be getting very low latency, and it will improve our user experience, etc. But it was not the case in the on-premise, because we will be having the data center, our like on-premise setup in only one location. Like mostly we will not get low latency. Okay, so this is the thing. So we have covered what is on-premise, what is cloud. Okay, so now let's see. So there are like different type of like cloud are there. So we have types of cloud. So there are different types. First is private cloud. Second is public cloud. Third is hybrid cloud. Sorry, cloud. Okay, let's understand the public first, then private. Okay, so let's understand the public cloud. So what does public cloud? So what we have in a public cloud is we share the same hardware and storage devices with other users. Okay, so when you request a machine, a virtual machine on a cloud, so you don't know on like which rack and like which machine you are you are allocated. You just have the instance name or some ID of that. So there might be a scenario like what is actually virtual mean. Let me for high level. So if you have, suppose this system, you have a single system, so it has like some RAM, some CPU core, some hard disk. So we can basically divide these resources into the like multiple machines. So this single divide can be virtually divided into multiple machines. Suppose I can create like 4 virtual machine out of this machine. So one virtual machine will be having 2 GB RAM, 1 CPU core, and let's suppose 256 GB data storage hard disk. So we will be having like 4 virtual machine we have created virtually. These are like separate environment are created. 4 separate environments are created, but in actual the physical device is the same. Okay, on a single physical device we have created the virtual environment, separate isolated virtual environment, and those we are referring to as a virtual machine. So you do not know like which machine you have been allocated when you request the machine on the cloud. So so on, suppose if you have requested a virtual machine, it might be possible on the same computer or on the same server someone like also have requested like machine, and that was also created on the same machine. That can be the case. So that why I said like we share the hardware and the storage devices with the other users in the private cloud or in the public cloud. So if we have, suppose like uh, very high uh, you know confidential data, uh, then we we should not we should not use public cloud, because it there will be security concerns. Okay, now let's move. to the next thing, that is private cloud. So what is private cloud? Here also we will get like on demand machines, or virtual machines or the services, but the cloud services and servers are hosted privately within your own environment, company's environment, using the proprietary software. What does it mean? Like you suppose it is like you have like on-premise setup, but then on-premise setup will be having like very less options, that will not be very efficient, and there are not much flexibility when it comes to the on-premise. But suppose now you have your on-premise, and there are some companies that have developed some software, so that those can be kind of installed on your servers that is there in the on-premise, and your on-premise will act like a cloud like setup that will do everything that a cloud, these public cloud can do. But in this case, you will be having your separate thing, your separate system. uh, so it will be very secure in general term. So it is like cloud like setup, that so where we can request machines, and it and these machines will be deployed on demand. It is like a cloud like setup only. So okay, so what are those companies who will like basically install their like proprietary softwares on our like on setup, on our setup? They will like come and they will set up make our on-premise like a cloud like a setup. So some of those companies are nothing but like VM, where we have Dell, and we have Oracle, etc. So this is a like a particular kind of private cloud. I would say on-premise private cloud. There are different kind of private cloud. You can like go through the theory of that you can do, but it won't be like asked much in the interviews. So you do not have to worry about much about these things. Just for a like high level overview, I'm just explaining these things. You just have a high level idea. So what is hybrid cloud? Hybrid cloud, it is nothing but a combination of both. Combination of both, meaning if a company has like if a company has uh, generic as well as let's say highly confidential data, then they will use they can use uh, you know uh, private cloud for confidential data, and uh, public cloud for generic data. So they are basically using the combination of both the setup. Then we are referring it like it is a hybrid cloud setup. Okay. So this is nothing but the type of different cloud types we have. Okay. So now let's see. So these cloud providers, they provide basically different kind of services. So what kind of services they basically uh, provide is, let me explain types of services. So we have like four type of services. First is infrastructure as a service. Then we have platform as a service. Then we have software as a service. Then we have serverless let me per serverless models. So let's see these services one by one. So let's see what is infrastructure as a service. So infrastructure as a service, this is like renting a computer over the internet. You will just get the machine. You will just get the machine and you have to install the software. You have to write the code and do development of your application. You will get only a machine, okay, or a server, you can say, uh, over the internet. And basically you will get a full control over this virtual machine, and you can install and can install software you need to build your application. It is like you are just creating a server and you can install whatever you want. Okay, it's just a pure server, or a pure machine. You will not get anything installed on there. You have to install everything you need, whatever you want, and then start developing your application there. Okay. And the another thing is, so the next thing is a platform as a service. So what and the example for it is infrastructure will be, uh, if I consider Azure, it will be the Azure, like virtual machine is there, virtual machines. So now platform as a service. So in the platform as a service, basically gives you a platform. Basically what you will get some machine. You will get some machine plus some software installed. So there are multiple services that comes under the platform as a service. So in those service you have some machine already, and you have the specific software installed. For example, we have Azure SQL database. This is one of the service that comes under platform as a service category. So what you are getting here, you have a machine, and on that machine the SQL server is basically installed. Okay, you can do the configuration changes whatever you need in your SQL server, and you can start using the same. Okay, so this is one of the example that I gave you. So this is nothing but a machine plus a particular software installed on that machine. What is SaaS? SaaS is a software as a service. So so you will get a basically a whole abstracted software, uh, basically hosted, and that too hosted in cloud. You will get a software or application hosted on cloud, and can be accessed uh, you know via internet. We do not have to maintain anything. We do not have to do anything in the SaaS. The example for here would be the Microsoft 365 Office 365. You just subscribe to the service, you take the subscription and you start using it. You do not have to do anything, because in platform service, what we were doing, we were getting a software installed on that, and we were using that software. We were doing some configuration changes, okay, in the software, in the SQL server according to our need. But here we do not have to do anything. We just subscribe to the service and start using it. So let's understand what is serverless model. So serverless model are nothing but where we just have to write some code, our logic, and that will be basically executed whenever that event is triggered, a particular event is triggered. For example, we have Azure cloud function. So what is cloud function? It is basically triggered by the events. So events can be like HTTP request. Event can be, some changes, then database, and etc. Okay, so these are some events. If these are basically happen, so it will trigger our cloud function, and whatever the logic we have written, the code logic, we have to write that. So whatever the logic we have written, that will be executed whenever these events happen. So the underlying the the basically the infra part. Infra means like the machine, uh, machines. What are the machines that are being used to basically execute our logic in the function? So that the infra part is basically taken care by the cloud provider. They will take care of everything. They when if the request is like, if you are executing something complex and that require more number of resources, then it will automatically scale. It will automatically basically scale uh, the resources. And whenever the less complex query is executed, it will accordingly basically allocate the resources. So this is our serverless models. The underlying things, the infra part is totally abstracted from us. We just have to write our code. We do not have to make any configuration changes in the cloud function, or the functionality part what is running in behind. We do not have to worry about that. We just have to write our logic. This logic will be executed whenever this event will happen. Simple as that. Okay, so this is the serverless model, and we have understood this. So we have covered a lot in this session, and let's meet in the next session and stop this session here.